Hi, in a previous video, someone left a comment asking if I could explain why 0 factorial is 1. So in this video, I'm doing it. Well, the short answer is 0 factorial equals 1 because we said so. We sort of just made it up. That's the short answer. The longer answer is, yes, it's a made up answer, but it was made up with a reason. And the reason was there are existing uses of factorials in math. And if we define 0 factorial as equal to 1, those existing formulas will work when we plug in 0. If we define 0 factorial as anything else and we plug it in, it won't work. So yeah, it's a made up answer, but there was a reason for it. So in this video, I'll go through three things. First, I'll explain why 0 factorial is not part of the definition of factorial. Number two, I'll go through a few reasons why 0 factorial might have been defined as equal to 0. It would be an okay answer, but it's not as good as, and that will be the third part of this video, is that I'll show you all the reasons why 0 factorial equals 1 is a much better definition. All right, so let's take a look at the definition of n factorial. You could define n factorial as multiplying all the integers up from 1, starting at 1, going up 1, 2, 3, 4, 5, 6, all the way up to n. Alternatively, you can define n factorial as starting with n and multiplying down to 1. Well, in order for either of these definitions to work, then definitely n has to be a positive integer. Because if you're going to go up from 1, that means you'll start from 1. There's no way you can start from 0. And if you're multiplying integers only, then n has to be an integer because otherwise you'll never hit it, right? So both of these definitions imply that n is an integer and n has to be at least 1. That means 0 factorial is undefined, not in the sense that we couldn't figure out what it is equal to. It's undefined in the sense that we didn't bother defining it. 0 factorial is just not part of the definition. We defined a thing called factorial, and we didn't bother with 0. So that's why 0 factorial is not part of the definition. It cannot be derived from the definition. It will have to be made up. What number should we set 0 factorial equal to? Well, I'll show you a few reasons why 0 factorial could be 0, but then I'll show you why 0 factorial equals 1 is a better idea. Could 0 factorial equal 0? Maybe. Let's take a look at the definition of n factorial that says that we're going to multiply integers from 1 up to n. And then so you go 1, 2, 3 and up, not going to be 0. Well, what if we cross out the word up? We're just going to multiply integers from 1 to n. Well, if that happens, then yeah, sure, we can multiply from 1 to 0. Then in that case, 0 factorial would be equals 1 times 0 and 1 times 0, 0. There, that's a possible way to justify defining 0 factorial is equal to 0. I'll give you another possible argument in favor of 0 factorial equals 0. And that is if we take a look at the permutation of n objects. Let's say we have 3 objects, A, B, and C. How many ways can we put them in order? Like A, B, C would be considered different from C, B, A because it's the same 3 objects, but it's in different orders. Well, let's figure it out. We could put A first. If we put A first, then what could follow? It could be B and C, or it could be C and B. So if we put A first, we could have A, B, C, or we could have A, C, B. Now let's put B first. What could follow? It could be AC or CA. Right? B first and then either AC or CA. Now I'm going to put C first. And what could follow? Either AB or BA. For a total of 6 ways. And in general, if we're given n objects, then there are n factorial ways of rearranging them. Okay, let's ask the question. What is 0 factorial in this context? In this context, 0 factorial would mean, given 0 objects, how many ways are there to rearrange them? Well, according to the formula, the number of ways should be 0 factorial. But let's say your job is to rearrange objects, and I give you 0 objects to rearrange with. Then how many ways can you do your job? No way, right? There's no way to do the job because you don't have an object in front of you to rearrange. Can't do it. There's no job to be done. And therefore, the answer is 0. I can't do it. I don't have a way of doing it. And since the number of ways of rearranging objects supposed to be 0, factorial, this is an argument in favor of saying that 0 is equal to 0 factorial. All right, so those are 2 possible arguments in favor of defining 0 factorial as 0. Now I've switched to different arguments in favor of defining 0 factorial equals 1. The first argument involves the same question, and that is a question of permutation. Given 0 objects, how many ways are there to rearrange them? Well, before we go 0 object, let me do 1 object. If I give you 1 object, I give you just A, and I tell you, rearrange them. How many ways can you rearrange them? Well, you sit there and you look at the A and say, oh, there's only 1 of them. How can I rearrange? So I'm just going to sit there and do nothing. On the other hand, the formula says the answer is 1 factorial, and 1 factorial is equal to 1. So in the case of 1 object, we count doing nothing as 1 way. What happens if we go down to 0 objects now? What can you do? Also do nothing. And do nothing, we counted it as 1. So 0 factorial is equal to 1. Same example of giving 0 objects and trying to rearrange them. You could argue that 0 factorial should be 0, or you could argue that 0 factorial should be equal to 1. So far, we're kind of even. Let's take a look at some more reasons why people prefer 0 factorial equals 1. A really cool argument in favor of n factorial equals 1 is to look at the pattern of n factorial as we take the number n slowly smaller. So let's start with 4 factorial. 4 factorial is 1 times 2 times 3 times 4, and that is equal to 24. 3 factorial is 1 times 2 times 3, and that is equal to 6. And how do I go from 24 to 6? From here to here, I could divide by 4. I could divide by this number, and I get to 6. So if I have n factorial, I divide by n, I get down to 3. If I start with 4 factorial and I divide by 4, I get down to 3 factorial. So guess what happens if I go down to 2 factorial? It looks like if I keep the pattern, I should divide by 3. 6 divided by 3 should be equal to 2. Does it work? Yes, it works. Because I'm really just omitting the extra factor here. All right, going down to 1 factorial, I should be dividing by 2. And yes, it is equal to the previous factorial divided by it. If I continue the pattern and I go down to 0 factorial, between 1 factorial and 0 factorial, I should divide by 1. And 1 divided by 1 is equal to 1. So 0 factorial should be equal to 1 if I follow this pattern. Combinations, choosing all objects out of n. Let's say I have 3 objects, A, B, and C. I'm asking you to pick 2 of them. Okay, I have 3 objects, A, B, and C. I could pick A and B, or I could pick A and C. I could also pick B and A, or I could pick C and A. These are 4 ways of picking 2 objects, one of which is an A. But A and BA are the same 2 objects. AC and CA are the same 2 objects. So at the end of the day, if you're going to pick 2 objects and A is one of them, then it'll be either AB or AC. Or you could pick 2 objects where B is one of them. You could go BA, BC, AB, CB. But BA is the same as AB, so that doesn't count. And AB is already picked, and CB is the same as BC, so that doesn't count. Or I could pick 2 objects where C is one of them. So I could have CA, CB, AC, BC, but doing the same as before. BC already showed up. AC already showed up. CB is the same as BC, so it doesn't count. And CA is the same as AC, so it doesn't count. So if I'm giving 3 objects and I'm asked to choose 2 of them, there are really only 3 ways of doing it. In general, there's a formula. If you're given n objects and you choose all of them, then the formula is n factorial in the numerator divided by r factorial times n minus r factorial. Well, what if r is equal to n? How many ways to choose n objects out of n? If I'm given 3 objects, A, B, C, what are the ways to pick 3 objects out of A, B, C? Well, there's only one way, is to pick all of A, B, and C. So the answer is one way. To choose n objects out of n objects, the only way is to choose all of them. So if r is equal to n, this has to come out equal to 1. Well, let's plug it in. I'm going to have n factorial divided by n factorial times n minus r, which now equals n. So it's n minus n factorial. Well, that's n factorial divided by n factorial times 0 factorial. The n factorials cancel, and I end up with 1 over 0 factorial. And this is supposed to be equal to 1. You look at this and you go, oh yeah, I'm so glad I didn't define 0 factorial equals to 0, because otherwise I'd be dividing by 0 here, and that's no good. And on the other hand, since 1 over 0 factorial is equal to 1, therefore 0 factorial has to be equal to 1. Here's a formula-based argument in favor of defining 0 factorial equals 1. Another argument comes from calculus, Taylor series, or in this case, Maclaurin series. F of x is equal to f of 0 plus f prime at 0 times x plus f double prime at 0 divided by 2 factorial by x squared plus f triple derivative at 0 plus etc. And the general form of it is I have the nth derivative at 0 divide by n factorial times x to the power n. Can I use this as a general formula all the time? Well, let's check on this one that doesn't have a denominator. This one, n is equal to 1, and the power of x is supposed to be n, so that seems to work. The derivative is supposed to be a single derivative, and that seems to work. I'm supposed to divide by 1 factorial, and that also seems to work because 1 factorial is equal to 1. So it works for n equals 1. Now, how about n equals 0? F at 0, I can think of it as no derivative here. I can think of it as a 0th order derivative. Does it come with x to the power 0? If I follow this form, yes, x to the power 0 is just 1. Or does it come with 0 factorial in the denominator? Well, it doesn't, but we can put it in if we define 0 factorial is 1. So yeah, Taylor series in calculus also suggests that it would be convenient if we could define 0 factorial as equal to 1. Now, going back to this screen, when I talk about the pattern of n factorial going down, I can make it more mathematical by saying that this relationship here, where I take n factorial and I divide by n, I get n minus 1 factorial. I can say that this relationship is the core of the definition of factorial. And that is the recursive property of n factorial. The recursive property comes out of the definition of n factorial. 1 times 2 all the way up to n minus 1 and then n. Well, this whole thing is n factorial, but this part here is n minus 1 factorial. So we have the recursive relationship that says n factorial is equal to n minus 1 factorial times n. Let n equals 1, then what happens? Then 1 factorial is equal to 1 minus 1 factorial times 1. This value is equal to 1. This is equal to 0 factorial times 1. And therefore, 0 factorial should equal 1. All right, so we have all of these different reasons why 0 factorial should equal 1. There are some arguments in favor of 0 factorial equals 0, but in general, because of all the big formulas using n factorial that we have, they work better with 0 factorial equals 1. That's why we chose to define 0 factorial equals 1. All right, hope that answers your question. Like, share, and subscribe for more contents. Any questions or comments, put in the comment section below. And thanks for watching. Bye.